Well, the lights went down and the music stopped, so I guess it's time for me to start talking. My name's Steve Eckeren. I'm a program manager in the Windows Server division. And just so you know, the lights are on me, you guys are dark. I can't really see you. And in this kind of presentation, we're going to do questions at the end, so that's okay. But just so you know, if I look funny at you guys, I'm not actually looking at anybody. I want to start this presentation out, first of all, thanking you all for coming in and being interested in this technology with our Windows Server 2016 and Hyperconverged. And also note that this has been a project we've been working on for over 5 years, and we've had lots of teams and lots of people working on it. And I get to be the one that's privileged to come and talk to you about the technology. And I just want to let you know I'm grateful for that. And I hope you all, when you look at the technology, you see the work we've put into it, and you'll see how it's going to help you and your companies be successful. So Hyperconverged. When we decided to do Hyperconverged and then start talking about Hyperconverged specifically with our technology, I went out and I just decided, what is my audience, or what are you guys going to be thinking Hyperconverged is? So I can start as a basis. And I binged it and I looked at a bunch of articles, and I found all sorts of things. For instance, network computing says they can run on any vendor's server hardware. And Tom's IT Pro says Hyperconverged is infrastructure systems that might resemble mainframes. And the cloud scaling article was talking about, well, there's Converged and Hyperconverged. Converged is pre-configured bundles of hardware and software in a single chassis. And Hyperconverged is technologies from scratch in a commodity hardware box supported by a single venue. And I came away with that saying, well, that doesn't make a lot of sense. I'm probably going to have to give you a little context about what we're talking about with Hyperconverged. So one of my goals of this session is to talk about our Hyperconverged solution, and make sure that when you walk away and you talk about and you go back to your companies and you think about your solutions, you have a good basis of what Hyperconverged solution is. I'm going to be talking about converged versus hyperconverged because we do offer both. I want to give you a good context to that. I'm going to be talking about the software-defined storage that's the infrastructure. The software-defined networking that we integrate with that's crucial to the success of the hyperconverged solution. I want to give you some good background and things to think about when you're looking at the networking for these systems. And I want you to have a good idea that we've done a lot of work to make these systems easy to deploy and easy to manage, and that you can be successful with these systems and be able to go back and start working with the technology and deploy it in your companies. I also want to make sure that I give you a good background. It's not just a bunch of, oh, this is all the cool things they'll do, but I want to give you some background and basis of how the technology works so you're comfortable with it. And also note that at I believe 4:30 this afternoon, Klaus Jorgensen and Cosmos Darwin, who are program managers in my team, have a session that's more of a deep dive into the particulars of how the data is laid out and how the system functions at a much lower level. So this session is meant to give you the good basis and background, and then if you really want to crave that getting into the more nitty-gritty, that session will give you that piece as well. So to start out with the background, what are we used to working with? I'm accidentally pushing the button, and it's okay. I'm going to go. Okay, let me reset just a second. But a traditional, the traditional storage array that we're used to working with is you have the compute systems connected to a storage array, and really inside that storage array you have components like the controller and the storage software. There's a backplane, and then there's a bunch of disks, right? And then you connect to that over some sort of channel like SAS or fiber channel. In 2012 R2, we introduced our first software-defined storage solution, which was the shared spaces. Still, in 2016, a very valid solution. You can upgrade your systems, and with this solution. But the idea of the shared storage spaces is you have the scale-out file server, and you bring that storage software for managing up into a server instead of on your storage device. And then backing it is a SAS connection with JBODs enclosures and a bunch of disks, just like a normal storage array with a SAN. And then the connectivity is through SMB, so your compute systems connect via SMB to the scale-out file server. And so you have the storage and the compute software-defined storage. And every single node of the cluster in this solution is connected via SAS to every enclosure. So if a node goes down, other nodes have connectivity to the disks, and so the data is always available. Then we can go into converged. So if you bring instead of having enclosures, you bring those disks up and you make them DAS disks. You use Storage Spaces Direct, our new 2016 technology. You can use the DAS disks, still have the scale-out file server. You have the software storage layer on the servers, and then you present via SMB the storage shares, the storage shares. With hyperconverged, which is what we're going to talk about mostly today, we go one step further, and we give you the ability to have a single set of servers that are hosting both the software-defined storage as well as host VMs. Now, we're the only company bringing a solution that allows you, with the same technology, to go and have converged, where you have compute and storage separate, and hyperconverged, where you have them together. And there's some reasons why you might want to have one deployment type versus the other. The hyperconverged market. People are really interested in hyperconverged. This is about 2-year-old data. The market then was about $1 billion. Okay. I'm going to go back here because I'm not pushing any buttons and my slides are moving forward, and I don't have any auto forward, so there's something else going on. Okay, so $1 billion market, fastly growing. There's several companies out there in the market, and so hopefully it'll stay here a second. So the companies out in the market, and we're bringing to the market a solution that we think is going to be competitive both in price, but I'll give you some information on performance, and I think you're going to be pretty astounded in what we can do with our hyperconverged solution. Really what comes down between hyperconverged and converged is how you want to scale. So a converged system where you have compute and storage separate has some advantages. One is you can have a separate hardware SKU for your storage that's got a lot of disks, maybe a little bit less memory, maybe a little bit less CPU resources, and then another hardware SKU that's for hosting your VMs. And for those, you want a lot of memory, a lot of CPU, but you don't need many disks. You just need to boot the servers and then connect to your storage. So for converged, you can scale out your compute separately from your storage. If you have a lot of VMs that aren't accessing much storage, you can keep your storage smaller and scale out your compute. If you end up having some VMs that are saving a lot of data into your storage, you can scale out your storage and do that separately. What we find is that the feedback from our customers is, and we really appreciate all the feedback you guys give us, is you want hyperconverged because you just want to have one hardware SKU. You have scenarios where you want to deploy, you don't need to deploy huge systems, huge scale, or you want to deploy multiple editions, multiple stamps of the system. You don't need one to be huge. And you want to just be able to add a node. And you don't want to have to add a storage node and a compute node. You just want to add a server that gives you the resources to run your system, both storage and compute. So hyperconverged brings that. And as I said, we're the only vendor that gives you the ability to deploy our technology either in the hyperconverged or the converged configuration. Now the basis for both the converged and hyperconverged platform is a technology that we've developed that allows you to take the direct access disk, the DAS disk, on a system, and instead of having every server connected to the disks. Only one server is connected to each disk, and then from the software layer, we actually have this thing called a software storage bus that when you enable storage spaces direct, it makes it so every node thinks it can see every single disk, and then you can put it into a pool, and then you can create volumes. And if we make sure it's resilient, we lay the data out across the disk, so if a node goes down or two nodes goes down, your system stays up and running, and your data is still available. Some of the advantages of software of going this approach versus shared storage is we use local storage, but it also allows us to bring in new devices. I've been working on failover cluster for 8 years, and with shared storage, you have to have very specific devices that support precision reservations, right? And so that means your SAS or your FiberChannel or your iSCSI. And people kept telling us, I want to use SATA disks. There's all sorts of new devices that are super fast, like NVMe. We want to be able to use that in our systems. And with Storage Spaces Direct, you can do that. You can use the NVMe, you can use the cheaper SATA devices, and it still provides that high available platform that you're used to with failover cluster. We have full management, deployment management with SVMM, SCOM, and PowerShell. We provide fault tolerance, so the data on the system is resilient, redundant, highly available. And we simplify. So since you have one set of servers and one set of management tools to work with both the compute and the storage, you don't have to go and say, oh, I need to go work on a SAN, so I need to go to my SAN UI, and I need to go do this and this. It's all in the software-defined layer. It's all in the operating system that you deploy. So some advantage and savings with that. So what are the things you think about when you deploy these systems, or specifically the hyper-converged configuration? Sizing is one thing. So with hyper-converged, people say, I want to start with I may decide to deploy with large scale up to 16 nodes, but oftentimes I'm going to be in branch offices or in scenarios where I want to start with 4. And so with 4, we allow erasure coding. So some people call it parity. And you can gain efficiency. So mirror is 33% efficient. So your data is redundant, but it takes more disks to store your data. With parity in 4 nodes, it's 50% efficient. And then as you go up, this is automatically moving forward. But as you go up, you improve efficiency with parity. So if you go up to 16 or 8 or 16 nodes, you get more efficiency with the parity. When you go to 3 node, you can't do parity. Parity requires at least 4 systems. But you do three-way mirror, and it's one less node in the system. You can save costs on hardware, less networking ports you're using, less energy. So 3-node might be a better solution for you. Lower cost of entry. You can scale out. You start with 3-node, you can add a 4th, you can add a 5th. I'll show you some of the nice management features we have. And it allows you to have, on a 3-node, 1 node can be in maintenance, and we'll still tolerate one of the nodes to fail, because there's 3 copies. Every node of a 3-node system with 3-way mirror will have a full copy of the data. So if you have that horrible situation, it'll still stay up and running, and you'll be able to fix your system or boot the node that was in maintenance, get back to 2, hopefully fix it to 3 when you're running in steady state. Now to do that, you do need to have a witness, because when you go down to 2, you need to have something that is your quorum vote. And in 2016, we provide 2 types of witnesses. One is if you have internet connectivity, you can do cloud witness. Easy to configure. It just connects to an Azure blob store. And in all of our testing, where we fail and test this thing, we have yet to generate enough storage I/O in Azure to get a bill that rounds off to a penny. So it's almost a free quorum device if you're connected to the internet. If you're not connected to the internet, or you don't want to use an Azure service, you can just have an SMB file share someplace accessible, and that can be your witness as well. So we give you the flexibility of both. As of yesterday, we announced for RTM, we also support 2-node. Now this is pretty awesome because there's some actual technical challenges with 2-node because of quorum. You need some sense of a tiebreaker. If one node goes down or they can't talk to each other, which node survives? And a lot of our competitors have quorum solutions where you deploy a VM somewhere else. Pretty heavy weight. We have this, like I said, almost free cloud witness or a file share witness, and allows you to have 2-node solutions. And obviously, if you have 2 nodes, it's a two-way mirror. Each node will have a full copy of the data. One node goes down, you stay up and running. So I'm a context guy. This next piece of the presentation is designed to kind of walk you through if you were to manually build a hyperconverged system based on deployment guides like TP5. But it hopefully gives you an idea of the components and what's involved in the storage spaces direct and hyperconverged configuration so that you can kind of understand the system. First thing you do when you build one of these things is you install the operating system. Obviously, that's a no-brainer, right? You do need the data center SKU. Storage Spaces Direct and Replica are 2 features that are exclusively in our data center version of Windows Server 2016. So make sure you have that SKU on your system. Join a domain. Configure the network. Now I'm going to jump out here in a second and give you more details on joining the network. But the idea is you do need to have your network configured. You install the Hyper-V role, the failover cluster feature, and then you create the cluster. Now, how many people here have deployed a failover cluster? Okay, nothing new here. It's exactly the same. There's no, this is things that you're going to be very familiar with. So basically, you create your cluster. Now, Storage Spaces Direct, very complicated. You're going to expect a whole bunch of steps to get this thing configured, but there's one. Enable-cluster Storage Spaces Direct. And in that PowerShell commandlet, or if you use System Center, we will automatically configure a whole bunch of stuff, and I'm going to go into details here in a moment of what that is. But basically, just enable Storage Spaces Direct. Create volumes, and then you can deploy your virtual machines. So let's go into a little bit of details of these steps, because we're not here for the highlight. We want a little bit of meat, right? Configuring the network. This is actually really, really important. This system, we have DAS disks on each node, and we rely on that network to talk between the nodes. When you have a write come in, and it's a 3-way mirror, you need that write to go to 3 different systems. It goes over a network between the nodes. You need that network to be low latency and high bandwidth if you're running a lot of IOPS through the system. So let's look at the networks. In 2012 R2, when you configured a shared space, space system, this is kind of the way the networking generally looks. You have NICs, 2 or more, that are connected to a NIC team, LBFO. That connects to the virtual switch. The virtual switch then has a management port, and then VMs connect to it. I don't think that's surprising for you guys. See, I need to back it up just slightly. Oh, okay. I have somebody that's going to fix it for me, so I'm going to keep going. Is it okay if I back it up, or am I going to mess you up? We're good? Okay. And then the next component is, we need that high-speed network. So there's 2 more NICs network controllers that you needed. We prefer they're RDMA capable, but they could just, be 10 gig E. And in that, through SMB multi-channel, things like live migration to CSV use SMB, and then the cluster uses the networks as well. In 2016, that old networking configuration is valid. You can still use multiple NICs. We want RDMA or 10 gig E at least, and then RDMA is our recommendation. So you can do the old networking with Storage Spaces Direct, and it provides services we need for the networking. But the direction is software-defined networking, and the feedback we get is that you guys would prefer not to have as many network devices. You would prefer not to consume as many network ports on your switches, because those have cost. So in 2016, we can go into what we call a converged networking configuration, where you just get 2 NICs, 10 gig a year better, preferably RDMA. You connect it to our new Hyper-V virtual switch with the switch embedded teaming, so the switch itself handles the teaming. You don't have the LBFO configuration separate. And that provides services for the VMs, and then it also hooks up that management port for the parent partition, so you can RDP into the system and manage it. New one? Thank you. What's different is, instead of having physical NICs for RDMA, we actually hook up a virtual NIC, or actually 2, because we want to be able to use SMB multi-channel, and to do that you need 2 port devices. So you do 2 virtual NICs, you make them RDMA enabled, and then you're able to hook up the same things we did before to physical, but to these virtual ports, and it all flows through the virtual switch with our software-defined networking stack, and it all gets flowed out through those 2 physical NICs. So you save on the number of NIC devices, you save on the ports, and then it's all configured via the software-defined networking, which gives you some simplicity and flexibility. Best practices. Like I said, the networking piece, since we're so reliant on these nodes being able to talk to each other in a very performant and reliable way. Use 10 gig a year better. If you're not running much I/O, then you don't have to have RDMA. But if you're doing a lot of IOPS through the system, RDMA gives you from our testing, gives you about 30% better throughput, less latency, and it also reduces your CPU utilization by about 30%. And that's important on a hyperconverged system, because on a hyperconverged system, CPU is a commodity. You want that utilization not to be used for infrastructure as much as possible. You want that capacity to be used for your virtual machines. So RDMA gives you that value of giving you back some of those CPU cycles. I'm going to talk about the performance in a second, but RDMA is one of the reasons that we can show the performance numbers that we have. And most of our competitors out there don't currently leverage RDMA, and once they do, we'll probably see their performance go up a little bit as well. RDMA, there's kind of 2 flavors out there for people that aren't real familiar with this networking technology. One's called Rocky, and in general, most adapters out there today are Rocky V2. And then the other one's iWarp, and we support both. The one thing to be aware of is that you want to make sure that your top-of-rack switches are configured correctly. In our betas, so we've been running the TP5 beta, and before that, previous betas. A lot of the issues that our technical preview customers ran into, we ended up root causing to the top-of-rack switches not being configured correctly. So our software-defined networking team has a lot of examples of scripts and configuration specifics for the major switches out there and how to configure them so that the RDMA flows correctly. Because if that network traffic doesn't flow correctly, can't talk between the nodes, and you'll see the system suffer in performance. CSV cache. Anybody here today use CSV cache and know what CSV cache is? Not many hands. Okay, so CSV cache has been around since 2012. And what it is it's a cluster functionality for our cluster shared volumes, where you can actually have a local read cache configured, consumes some memory, RAM. But what it does is that as a read comes into this S2D system and hits a node, the first time it will have to go and get the read from somewhere. But then it populates the cache. So if something reads that same data again, the same block of data again, it just comes from cache out of memory, and it's super fast. So what we find is with Hyper-V, particularly if you're doing remote desktop, you have golden images, things like that. If you run CSV, your performance can just skyrocket and get much better performance out of the system. So think about enabling CSV cache. Then the next question is usually how much, because you specify it. It's a global setting in the cluster. You specify it by the number of megabytes or gigs. And the answer is, it's that give and take. RAM is a commodity for VMs. You don't want to set it huge and then have less RAM for your VMs, but you want to have some. So usually we say start with a gig or two, see how that works, adjust it. You can change it on the fly. It takes a reboot of the system, but you can change it, reboot the systems, and test it. But start with 1 or 2 gig and see how that does for you. If you're not doing a lot of IOPS, it may not even be worth it. But if you're looking at increasing your performance, look at enabling the CSV cache. So we go back to our workflow. Creating a cluster. So I noted that everything up to this point is the same old, right? There's one caveat. We actually updated the cluster validation tool to have tests specific for storage spaces direct. So if you've enabled storage spaces direct and you run validate, the tests will automatically be included by default. However, if you are running it before you enable storage spaces direct to just see if the system is going to be okay, you need to either in the wizard check the box manually, or there's a PowerShell down below that does an include statement that will include those tests. But what it'll do is it'll go through and it'll look at the systems, look at best practices. It's actually really fast. So in the past, failover cluster got a really bad reputation for storage tests taking a long time. This actually, because we don't have persistent reservations, we don't have that mechanism anymore with storage spaces direct of having to verify that the disks and the controllers are operating correctly with persistent reservation and all that challenge and defense and the full matrix of all the disks and all the nodes. All we have to do is check to make sure that the disks are the right type, and it seems like your best practices are followed, the right components are there, so it's really quick. And as a side note, we actually did a lot of work in 2016 for the regular storage tests as well. So if you're working with the SAN, iSCSI target, SAS, like before, and you upgrade to 2016, you run validate, I think you'll find it's a ton faster, like orders of magnitude faster. So we've heard your feedback, and we took care of that as well. But that's really, when you enable the cluster, that's really the only difference when you're doing a storage spaces direct or a hyperconverged system. So this is where some of the meat is. In our first previews, if anybody worked with storage spaces direct in the previews, our deployment guide had a whole bunch of steps. You had to configure journal drives, you had to go and claim disks, and you had to create the pool and do all these steps. And we came to the conclusion that if we can describe what the logic is and make recommendations to you of how to configure the system, why don't we just put it in code? So in our enable cluster storage spaces direct commandlet, we did that. So when you run that tool, if you can set parameters and influence the defaults, but by default, we do a whole bunch of cool stuff for you. First thing we do is we go and claim all the disks. And we'll use all the disks that are available in the system. Now, what makes a disk available in the system? It's got to not have a partition on it, because we don't want you to accidentally put a disk in one of these servers that you're building that may have been from a system and you didn't realize it had important data on it, and for us to go and remove it without you guys saying it's okay. So the disks have to have no partitions on them. So if you're reusing disks, make sure you clean the disks before you put in these systems, enable S2D, and it'll make things much better. We also ignore any disk that the operating system's using. So it's got a page file on it, it's got the operating system on it, the boot system. We'll ignore those. And everything left over, we bring into storage spaces direct. Next thing we do with those disks is we create one large pool. Now in shared spaces, we said, well, you might need multiple pools because we don't really want you to have more than X number of disks in a pool. I think it was 80. And the reason for that is in normal spaces and pools, every disk has metadata on it. So the information that describes the pools and the virtual disks and which disks are part of which pool, that's copied to every disk. And when you get past a certain number, A, why do you need 80 copies of the metadata? B, every time you change something, it has to be acknowledged and written to that many devices. And it's just, it doesn't scale well. So for storage spaces direct, we take advantage of we actually designate which disks in the system are metadata disks. We make sure they're spread across nodes, and so that if nodes go down or disks fail, there'll still be enough copies that you always have a copy. You're not worrying about resiliency. 80 copies is crazy resiliency. You know, we do 5, and that's plenty. And then we also make it so we watch it. So if a disk fails or a node goes down, and so one of those metadata disks is unavailable, we just elect another disk to be metadata disk, copy the data, and we always keep a good number around. So we just do that automatically, and it gives us much better performance when you scale out to a much higher number of disks. For RTM, we're recommending about 240 disks in an S2D system, whether that's 4 nodes or 16 nodes. And Klaus will get into the reasons why for that. We'll eventually go much higher, but for now, that's what we test and we're comfortable with as far as rebuild times, et cetera. We also, I'm going to talk about cache, and one of the reasons why we're so screaming performant, have such awesome performance, but we have this cache device that we configure. And so in this diagram, you'll see some of the disks, which are actually, in this case, the SSD disks, are marked journal. And it means those disks are being used for our cache. Speaking of the cache, so what we do is, if you have more than one media type in your server, Enable S2D analyzes the disk and the media type, and we'll say, oh, in this case, this system has SATA SSDs, and each node has SATA HDDs. We're going to take the SSDs, and we're going to make them cache devices. The cache devices then are bound to what we call capacity devices. And some people think of it, our vSAN has disk groups, so they have these disk groups, and you have an SSD and a hard disk. We don't define disk groups. We have defined cache groups and the binding to the capacity devices. And if one of those cache devices fails, instead of everything going offline and not being available until you fix the device, we just rebind. And so you can have an SSD fail. The system will stay up and running. All the data will still be there. You'll be slightly less performant because instead of 2 cache devices, you have 1. But when it's replaced, then it just goes back to normal state. As a matter of fact, we do that automatically. It's round-robin binding. And we note that if you were to look at those SSD devices, they're oftentimes used for that metadata for spaces and pools. So instead of taking the whole device, we leave 32 gigs of the device open for metadata, because we want the metadatas to be so fast we put them on the fastest devices. And then the rest of those devices are used for cache. So what are the considerations? We do use some RAM to manage the cache devices. The structure, the cache devices are persistent, so any data that goes into those cache devices survives reboots and being removed and put back in. But you need to manage the structures on it. And instead of taking overhead from the cache devices for managing the structures, we take a little bit of RAM. So for every terabyte of cache, we use 4 gigs of RAM. So when you're looking at how much RAM do you want on a hyperconverged system, one of the things to consider is that depending on how many cache devices and the size, some of that RAM will be taken up. I also noted that we bind the cache device to the capacity devices, and the system is most performant when it's balanced. So if you have 2 cache devices, have an even number of capacity devices. If you have 3 cache devices, have a magnitude of 3, so that each cache device has the same number of capacity devices bound to it in steady state, and then you get the best performance and balance. Storage tiers. Now this is something that Klaus's session this afternoon will go into greater detail. But we do tiering differently in Storage Spaces Direct and in 2016. Previously, when you created storage tiers, you dedicated performance devices like SSDs and capacity devices to a tier. And then if you had VMs that were consuming that was great. But if you didn't, and another volume that had a separate set of devices really could have taken advantage of it, it wasn't able to because it wasn't shared. So we changed the tiering mechanism in 2016 so that instead of dedicating physical resources, you're able to just define volumes with how much space you want from a tier. And the tiers not only are media devices, But tiers now can also include resiliency type. Becomes very powerful because now we can create a volume that has mirror and parity on the same volume. And I have some slides here that show you some of the advantages, but it makes it so that you can use your hardware resources, your performance resources, in a much more efficient way. So here's a kind of a table of, if you have X number of nodes, we automatically define tiered definitions that one of them is called performance and one's called capacity. And for instance, if you have 4 nodes, you can have parity as part of your tier definition for capacity, but if you're less than 3 nodes, you can't. So there's this matrix of how many nodes, what are the media types, and instead of telling you guys, here's the matrix and go configure it yourself, StorageSpaces Direct, when you configure the system, analyzes it and creates the tier definition with what we believe is the best performance devices and resiliency and capacity devices and real resiliency, and we name them performance and capacity. So after that, you create a volume. So I just talked to you about the tier definitions we created. Well, that comes into play when we create the volume. REFS is a recommended operating system, or a file system, sorry, for StorageSpaces Direct, and there's a couple really good reasons why. I just described that you can create volumes with mirror and parity. That requires REFS. You can't do that with NTFS. VM snapshots are much faster. Creating VHDs, that fixed VHDs, we have a demo down in our demo booth. But creating a fixed VHD that would normally take 4 minutes, you can do in a couple of seconds. So when you're working with virtual machines and you're working with storage spaces and volumes, REFS brings in some features that makes a solution really valuable. There is one big thing that REFS does not support yet. And believe me, we've heard from you guys about this. Dedupe. Dedupe does not support REFS yet. It's on their list. So we expect to have it done soon, but it's not right now. So if you have anything that you want to use dedupe, backup archive or usually a remote desktop scenario, use NTFS. That's perfectly valid. It's just you don't get some of the benefits of the snapshot speed and all that with NTFS, but it's still a valid file system for StorageSpaces Direct. This is really cool. We are the only company that has this ability to create volumes with mirror and parity. And why is that a big deal? Parity is horrible for writing data. The way parity works is that you have some data and then there's a parity bit that's calculated based on the data. Every time you write to it, you have to read in the data, you have to recalculate the parity, write the data, done. That's CPU cycles. It's slower. Mirror is much faster, but it's 33% efficient. So you feel like you're spending more on buying hard disks than what you're really gaining in storage capacity. And we're able to give you the ability to create a volume that has mirror and parity. And why is that interesting? Well, with REFS, we make sure that all the writes that come into the system go to the mirror section. So it's fast. There's 3 copies. It's fast. You don't have to do the parity recalculation. And as that mirror section fills up, we'll, in the background, in large chunks, which is efficient, rotate that data into parity for more efficient storage. And then some of that logical block addresses that were set for parity we'll put back into mirror resiliency. So you always have that same size. So you get the advantages of parity for your capacity, but you get the performance advantages of mirror. So people say, well, the stack's kind of complicated. You got the cache, you got these REFS and the volumes. If I do a write, can you kind of describe to me what that looks like? So REFS a write comes in, it'll go to a logical block address in the mirror section of the volume. Storage pool says, oh, that logical block address has resiliency of 3-way mirror. I need to write it to 3 different nodes, finds the nodes where the slabs are for the resilient copies, sends the writes out. When it gets to those nodes, that's when it hits the cache. So it sends the write out to the 3 servers. I have the 4 arrows because there could be lots of writes going on. But if it's 3-way mirrored, go to 3 of the servers. It'll hit the cache. The cache is super fast at responding back. Yep, confirm the write. And then we can send it back up. That's what gives us our screen performance. So I've talked a little bit about how the system's built, the components of the system, and we went through that list of about 8 different steps for creating the system. But in reality, we've made it a lot simpler. First thing I want to talk about when deploying, we do find that when working with the SATA disks, the SATA controllers, some of the SAS devices out there, there are some devices that have not been tested or validated to work at the number of IOPS that we can push at them. And when you push a ton of IOPS to some devices that are out in the market, they'll reset, or sometimes they just halt for a while. And that's not very good for a system that you want resilient and performant. So we do have this software-defined offerings. We're working with all the major OEMs. They're verifying the solutions on all the controllers, the disk types, the firmware. In some cases, it just takes a firmware change to make a device from something that halts at high I/O to being really good. So when we're at release, we would really recommend any production system that you guys put out there. Go to your OEMs, ask them for what systems they have in their software-defined storage offering, and then you will have a confidence that they've tested it, have the right firmware, you have the right devices. It will work great in the system. If you want to test it and play with it, if you're not pushing a lot of I/O through it, almost anything works. I have three desktop systems with 1 gig interconnects and 8 gigs of RAM and just some spinning media, and it works. I just can't do much IOPS with it. But for production, use the validated hardware, work with your OEMs, and make sure you get the right hardware. So now you've heard me talk for a while. Let's do a little bit of a demo. Show how easy it is. So right now we're going to show you, this is a 3-node system. We go to get physical disk. You can see that on this particular node, we've got 4 hard drives and 2 SSDs. We're going to create a cluster, simple PowerShell command line. It's going to be 3 nodes. We give them node names. Creates the cluster. Now we do get cluster node. We show you we have a 3-node cluster up and running. Now this is enable cluster storage spaces direct. It does all that logic for creating the pool, getting the disks. We're going to ask you, do you want to do that? Yes. Then we say create a volume. It does a for each for 5 volumes. It's going to create 5 volumes. We've now created a 3-node cluster, storage spaces direct enabled, 5 volumes. And we kind of fast forward through this, but in real time, this took us 15 minutes to create the system and about 3 PowerShell command lines. Well, we can make that one better. If you have System Center Virtual Machine Manager, they've integrated storage spaces direct with the creating a compute cluster. In this case, we have 2 sites, Atlanta and Seattle. In Atlanta, we have 3 nodes. Looking at the resources of the nodes. We're going to go up to the home. We're going to create a Hyper-V cluster. Give it a cluster name like you would normally do. Pick the host. We want it out of the Atlanta group. And there's a checkbox. Enable storage spaces direct. And it's going to note to you that when you enable this, it's going to create the pool and it's going to create the tiers. The journal drives will be selected. The cache devices will be selected. Go next. Give it an account that allows it to create the cluster. And then you pick your hosts. We already said it was in Atlanta. Those are 3 hosts currently in Atlanta, so we'll take those 3. Give the cluster an IP address. and then it'll go do the job to create the cluster. Now, it does take a few minutes for SCMM to create any cluster, because it's going to go and do all the configuration, install the features, the roles, reboot it, enable storage spaces direct. So while it's doing that, we're going to show you another cluster that's already in the Seattle group. We go in, we look at the volumes, and we selected to create a new volume, give the volume a name. How big do we want it? Now in this case, there's only one tier because there's only 3 nodes. You can't do parity, so there's one tier. So capacity, it says how much space do you want, finish. And then we go back, look at the jobs, and we created a volume on the system. Pretty simple, a checkbox and a wizard to create volumes to manage the system. So System Center has full integration with Storage Spaces Direct. You can bare metal provision, but if you have a system that was already built by an OEM or you went and built it yourself, System Center can attach to a Storage Spaces Direct system, a hyperconverged system that's already been created and start managing it. Full support for VM management. It also has integration with storage quas. Why is storage quas interesting? Well, in hyperconverged, like most systems, you don't want one VM or a subset of VMs to take up all the capacity of your storage. So we have the ability in our platform to apply quas policies to the virtual disks of the VMs so that you can either limit the amount of IOPS that a certain VM has, or we're the only people in the market that has a quas solution that will allow you to provide minimums. So if you want to say have a default policy that says every VM on your system should at least get 100 IOPS per second, you can set that and you guarantee it. If you have certain VMs or people that are hosting VMs that you want to limit the amount of IOPS, you can go do that. And it really helps you manage your system and make sure that you get some fairness. Also, Storage Replica is fully managed through System Center. So if you're working with Storage Replica, System Center manages all those workflows as well. But we also have inbox management. So if you're not running System Center, particularly if you're running branch office or scenarios where you're doing smaller deployments, it just makes sense to just go do it or have your own scripts. We have full PowerShell support, as well as our inbox GUI for RTM has been updated to be compatible with Spaces Direct. For instance, here's an example where we have a storage pool on a Storage Spaces Direct system. You just go and say, I want to create a new volume. You get the virtual disk. You get the new virtual disk wizard. And in this system, we actually have 2 tiers, one performance, one capacity. Gives you the ability to specify the size for each. So we're going to say 50 for performance tier. Capacity tier, we want 250 gig. My total disk size is going to be 300 gig. Press next, and it creates the virtual disk. Pretty simple. Just integrated with Failover Cluster Manager. And most people running failover clusters are very familiar with this UI. Health service. Seems like a simple thing, but it's actually a really big deal. We've integrated a highly available service into the Failover Cluster platform that allows you to do it allows you to get a view into the system that's unique, but it also allows a lot of the automation that you'll experience through the system. For instance, one monitoring point for everything. And in the 430 service presentation, they'll get into the nitty-gritty. But basically what this does, in the past, if you want to know, well, I have a scale-out FAS or a hyperconverged system, how many IOPS is it actually producing? And you have to go to each node, get the perf counters, and then put it into a spreadsheet and calculate it. Now we have a PowerShell commandlet that you can call, and it aggregates that data for you. All sorts of data about the system. So it makes it really easy to understand, not just per node, but as a system. What are the performance attributes and what is it doing? Aggregated metrics. We also are taking scenarios like disk replacement. In 2012, if you know the 2012 R2, if you wanted to replace a disk on a shared storage system, there's like a 2-page document on the steps you need to do. You need to retire the disk, you need to do this and that, and then add the disk and add it to the pool, and then kick off and optimize. We said that's crazy. So we went and had the health service. It can see what's going on in the system. And it's as simple as it'll see that a disk has failed. It'll give you a fault. It'll give you the information about where that disk is, what server, what rack, and what slot. And you go pull that disk out, put a new disk in. It'll see that a new disk is in there automatically. It'll automatically add it into the system. So it's as easy as pulling the disk out and putting one in. It's pretty cool. Cluster-aware updating. So it seems like patching a system should be pretty easy. But in some distributed system like Storage Spaces Direct, you have multiple nodes, and you need to make sure that your system stays up and running and people are able to access the data. You don't want to have more than one node down at a time, and you don't want to start the next node until a node comes up and any of the writes that happened on the system while the node was down, till that's all synchronized. So we've updated cluster-aware updating so that it's got the logic that it's a Storage Spaces Direct system when it runs on it, that it'll look to make sure that all the virtual disks are healthy, the system is stable. It'll analyze what patches that node needs based on your baseline or what Windows Update tells it. And then it'll migrate the data off, the VMs off the system, patch the node. If it needs a reboot, it'll reboot it, bring it up, and then it waits for the virtual disk to fully resync and be healthy again, and then it'll go to the next node. And it'll cycle through all your nodes, and it'll make sure that your system's up to date and healthy. But it does it in a way that's very safe, and will make sure that your system stays up during the process. In hyperconverged, we've talked a lot about storage, but like any system that hosts virtual machines, there are some considerations that you want to look at. For instance, a 2-node system. If you're running a bunch of VMs, sometimes you're going to have maintenance windows or failures. That means that you need to be able to host all those VMs that are important to you on just one node if it's down. And so it's important to take that in consideration when you're looking at how much capacity the nodes are based on what are you expecting to host, and if a node's down, can that other node take it over? Now, in scenarios where you have, you say, well, it's 2 nodes, but I have some VMs that aren't really important. And so if I go down to one node, I don't care if they're off for a while until the next node comes up. You can actually go in and set the VM priority in the failover cluster to low. And so if they all get squished onto one node and there's not enough resources for some of the VMs, the ones that are low will pause, we'll take offline, and then as soon as the node's back up, we'll automatically bring it online. So we have ways to manage that. But in general, you want to be able to ensure that if you do have a failure and node down, that you have enough capacity for your virtual machines. Also realize that the number of nodes does affect the type of resiliency that you configure. 2 nodes, you want 2-way mirror. 3 nodes, you want 3-way mirror. Then a common question is, well, why don't you recommend doing 2-way mirror on a 3-node system? And the reason for that is we want you to have the ability to have a node down and still tolerate a node failure. And if you only have 2 copies of data, the way we stripe out the data and distribute it, if you have a node down and it's 2-way mirror, you'll be fine. But when the second node goes down, there'll be some piece of the volume that those 2 nodes are where the 2-way mirror of that piece of data was, and so the volume will become unavailable. You won't lose data, and it'll become available again once one of the nodes comes up. But you lose the ability to have a node down and a node failure with a 3-node system. So we recommend 3-way mirror for the 3-node system. 4-node gives you parity, so you don't have to use it. You don't have to define your virtual disk with mirror and parity, but we give you the option. It's there. You gain some capacity. You gain some efficiency when you use it. So you have to have at least 4 nodes for parity to work. Klaus will show you how the LRC algorithms work and how the data is placed in his session. But anybody that does erasure coding, all of our competitors, you need to have at least 4 nodes to do it. We're no different. So I've been teasing you a little bit about perf. How many people have been on the demo floor and seen some of the perf numbers of S2D? Because there's like Lenovo and IBM are all doing demos with S2D. Not many. Okay, good. I get to tell you about cool stuff. Throughput. On a 4-node system, 80 gigabits of throughput. Read. That's a lot. 1 million IOPS. So in our systems, and we did this actually about 4 months ago on a 4-node system. And we're not doing all flash. This is SSD used for the cache. And we talked about how the storage space direct cache works. HDD is capacity devices. And we can get 1 million IOPS out of a system like that. If you go down to the booths downstairs, for instance, Lenovo, they have a 4-node system that's all flash. And they are showing over 3 million IOPS per second on a 4-node system. One of our large competitors touts that they can do 100,000, with all flash, they can do 100,000 IOPS per node, which would be about 400,000 IOPS if you calculate it out, right? We can do, with HDD, 1 million, and with all flash, 3 million. And when you go to 16 nodes, actually one of the keynotes, I believe, Mike Neal in the keynotes. A couple months ago we did 5.7, but now we show over 6 million IOPS per second with 16 nodes. Who thinks that's cool? I don't know of a system where you have 4 nodes and enough VMs that you're going to consume, even 1 million IOPS versus 3 million IOPS that we're able to provide you. So you don't have to worry about IOPS when you work with our system. Go play with our technology in virtual machines. So here's another thing that we have different than a lot of our competitors. Most of our deployments in production will be on physical machines. However, we're just a software layer. You can create a test environment, spin up 2 or 3 virtual machines, hang some data disks off of them, enable storage spaces direct with those data disks, and then see how our management tools work and see how the working with the system works before you go and buy some hardware. Remote desktop services. There's actually solutions being deployed in Azure today where they needed to have file shares up in Azure VMs that they're able to ACL and permission with their own perms. And so they're supporting storage spaces direct with a failover cluster and a scale-out file server for these remote desktop solutions, and then use storage spaces direct as the high availability. So you deploy 3 virtual machines or more. You need to use their premium storage to get the IOPS that you want from the VMs, premium storage option. But then you can create S2D in a scale-out file server and then manage it just like it was on-prem. And you get the high availability and all the advantages. So not only can you do physical with hyperconverged, we also have the ability to use these solutions in virtual machines and in public cloud. So here's related content. We have a whole bunch of presentations going on. I broke out today's sessions here because it's a little bit easier to read. At 4 o'clock, it's a breakout with Klaus and Cosmos. But at 10:45 today, we have enterprise-grade building blocks with Windows Server software-defined partner offers. So if you're interested in the ecosystem and what the hardware what hardware is out there and some of the details of that program, you can go to that breakout session at 12:30. There's optimizing software-defined storage investment in 2016. You go to that, and then the cloud session is at 4. Thank you for coming to my session. I hope I gave you some background not only on the value that we can provide, but the performance, the ease of management, and how our solution can help you run your companies better. And I really do appreciate you coming, and please fill out your evaluations. We always appreciate when we get the feedback. Thank you.